Ever wondered how stars form in space? They're very large bodies and they're made up of an extremely large amount of atoms and other particles. And there's several processes that go into the formation of a star. Today I'm going to be starting from the very beginning down to the level of subatomic particles such as quarks. For this speech I'll be talking about up and down quarks, but there are others such as the strange and the charm and the top and the bottom quarks, but we won't be discussing those. A proton is made up of two ups and a down quark, an up quark being 2/3 of a positive charge and a down quark being 1/3 of a negative charge, equaling out to one positive charge. And a neutron is two down quarks and an up quark, equaling to a neutral charge. The quarks are found generally in groups of 2 or 3, and this is because they're held together by the weak nuclear force, and the weak nuclear force actually gets stronger as quarks get farther apart. And scientists have tried to separate them to see what a quark by itself would be like, but it takes so much energy to separate the quarks that you end up putting enough energy into the system to create another quark, so they just make another pair. And so you have the quarks, and they create the protons and neutrons. Electrons are their own thing. They are not made up of quarks, but they're affected by the electromagnetic force, which goes into the formation of an atom. Protons have a positive charge, and positives don't like going together, but you've heard of other elements other than hydrogen. This is because the strong nuclear force is much stronger than the electromagnetic force, and this holds the atoms together very tightly, and it also allows neutrons to be thrown in there. Electrons, being a part of the electromagnetic force, orbit the atom in a circle, but this is a simplified model usually. It was thought of first by Niels Bohr, but it's more of an electron cloud type of thing, where you can't really know where the electron is. Anyway, you have the atom and the electron, and this creates your element with a charge. And over longer distances, the weak force and the strong force and the electromagnetic force aren't very strong, and this is why you can have large amounts of matter together, because gravity is much stronger over distances, and you cannot have a negative mass, which means the more you have of something, the more gravity there will be, period. So they can't cancel out like any of the other forces. So after you have a certain amount of mass in an area, everything will start to coalesce into, in space it usually starts off as a cloud called a nebula. Nebulas are extremely large, and there are quite a few of them in our galaxy and other galaxies. For an example of one is the one that formed our solar system, and it started off, when our star was a nebula, it started off roughly the size of our entire solar system, and eventually condensed as particles bumped into each other and stuck to each other. And this is where we got the sun and the other planets. When a nebula starts to combine, it happens quicker and quicker as the mass starts to build up in one central point, and eventually it will get to the point where the body is spherical from its own force of gravity, and it has a cleared neighborhood, and this is when it would be defined as a planet. And after a little bit longer of adding on mass, it will eventually reach a point where the amount of pressure put on the matter will cause it to enter a new state called plasma. This is when the star will quote-unquote ignite and nuclear fusion can start to begin, and this is when stars will burn. Once you have a star, they're categorized into several different categories. There's 7 different letters. These are from dimmest to brightest: M, K, G, F, A, B, and O. These letters are used to describe the general temperature of the star and the general size of it. They go from red to yellow white to light blue to dark blue, darker blue, and even darker blue. They just start getting blue. After a point though, when a star starts to become too large, it starts to become unable to push back against the amount of gravity that's being put on it. And this is when a star will eventually collapse into itself and become a black hole. But before it becomes a black hole, it will go through a stage called a neutron star, which is kind of an awkward in-between stage, where it has extreme gravity like a black hole, but it doesn't really have an event horizon, but it isn't a true star anymore. Neutron stars usually have a spin to them, and this is what is defined as a pulsar. And they are some of the most scientists use pulsars as a timing, because they're extremely accurate with how many times they will revolve and flash. And as the neutron star gets bigger, it will eventually become black holes. And black holes are extremely large, and they create just unimaginable amounts of gravity. As far as we know, or we have no way to describe what happens in the center of a black hole. As far as we know, the laws of physics may not be accurate inside of it. But that is the formation of a black hole and stars.